Hey guys, Jay Young with Young Red Angus. Wanted to put together a quick intro to set up today's video. I had a conference call with some agronomists from biomakers to discuss the lab analysis of our compost. And so I'm really excited about the results. We had 365 species of bacteria and 305 species of fungus. And so the video is just about that breakdown and how those microorganisms help you break down micronutrients, specifically inorganic nitrogen, and make it plant available. So if you're into commercial agriculture or you're into composting, this is an important video for you because we have so much nitrogen sitting out there in inorganic form that we can access through compost, specifically ours, Johnson Su, but it doesn't really matter as long as you're making good compost and applying it in furrow with compost extracts. So I hope you enjoy today's video.
Got it. All right. So Jay, the one I've got pulled up here first is that sample A. This is the one here, if you're able to see that. So like I told you yesterday, we used 16S and ITS genetic sequencing to identify the fungi and bacteria in your sample. So we've got a database of about 7.7 million organisms, and we know their functions and their roles in the soil. And from that, we can produce these reports. So in this compost sample A that you have, we had 670 organisms that we identified.
Just the bacterial and fungus organisms, correct?
Yes, that's the bacteria and fungi. And then right below that, we list the most prominent phylums of the bacteria and the fungi that was in the sample.
Yeah, so, and that's what I was wondering what those were, but I wasn't picking up on that was the name of the species of fungus. So are these all on the fungus side, or are these all saprophytic funguses that are eating on dead plant material, or some of them other types of fungus?
No, these are beneficials, and some saprophytic. For the most part, they're the fungi like trichoderma, penicillium. You'll see them in the report at the bottom. Out of the 670 species, how many were fungi?
300.
Yeah.
Yeah. So that's what it was.
These are all beneficials for the most part.
Okay. Is there if they're non-beneficial or what?
We've seen reports where you'll see fusarium and you may see, but for the most part, the secondary organisms become food for these guys here. These are the primary pool. These are the ones that feed on those secondaries. So if you have a pathogen in a corn crop, let's say you have Phytophthora or fusarium, it's usually there because the biology from the primary pool is weak, and that's trying to kill that plant to feed the primary pool. These are the guys right here that actually do the work.
Okay.
So if you build up your immune system with this stuff, you're not going to have the secondary issues.
Sure. Okay. You're talking about the soil specifically.
I'm talking about in the soil, but I'm talking about compost products too. Anything that's breaking down tissues to feed, that's what they're doing. They're breaking down old plant material to make available nutrients for the next generation. So that's how these work. That's the whole process here. So when you have a composted product like this one, you're looking at the species that are there that are beginning to break down those old carbon sources to feed these primary bacteria and fungi.
Okay. Well, on these two different samples, I'm embarrassed because I lost what sample was what, but just by the results, I'm assuming that the sample A comes from my compost that never went anaerobic. And then the sample B would be the compost that went anaerobic. I mean, none of my compost is currently anaerobic. It all fixed itself over time, but I'm guessing that time anaerobic.
I would say the one with 600 species, the anaerobic got really hot, didn't it? It got up to above 160 degrees probably.
I think it was probably around 158.
It killed that. When it gets hot like that, it kills the species.
Okay.
So the one here that's 324. Yeah,
because the fungi to bacteria ratio is way off on this 324, whereas sample A, it's pretty well 1-to-1.
Yeah. Well, I used more wood chips and ground up corn stalks, and so I'm guessing the ground up husks. Cobs and stalks within the corn stalks and the wood chips really helped airflow and kept it, probably since it's a higher carbon source, probably helped it from getting so hot.
Yeah, that's right. So do you turn them or do you put air in them or?
Now, are you familiar with the Johnson Su method?
I am. You're piping air into the pile, right?
Yeah. So on the sample B, I would have had to have broken apart. Well, some of those I broke apart, and others I just poked a bunch of holes through to get airflow into the compost. And then one of them I broke it apart, added wood chips, and put it back together. I had eight piles, and 7 of the 8 went anaerobic. So I had a bunch of stuff that I played with trying to fix the ones that were bad. But I raised 200 bushel corn with no nitrogen and no phos applied in a test strip. And so that would have been with this sample B. So even with the less fungal component, we were still able to see the biology from this compost that was less diverse.
What are these? What are these pathways? I haven't seen this product. What do the pathways look like?
So species are less, but the pathways are pretty well consistent amongst both products. They both have the same functional levels. Biocontrol's low. What was that, Jay?
What is the pathway? So I'm following you.
Okay, when you get down to the nutritional part of the report, it shows it in the red letters.
Okay.
We're looking at the organisms associated with the carbon cycle.
Okay.
We're looking at the fixation, the aerobic respiration, the fermentation, the methanogenesis. We'd like to see losses sometimes in that area.
Okay.
Because we want to build up organic matter. And the bottom line is, are we mineralizing? Are we sequestering carbon?
Okay.
Same is true with the nitrogen cycle. So when you see that percentage at the top there, the inorganic nitrogen release, that's the organisms that are responsible for mineralization and making nitrogen available to the plant.
Okay.
So out of your, what was this one, Jared? 300 and something?
324. Yeah.
Out of your 324 species, 87% of those are going to make nitrogen available. Okay. They're helping move nitrogen to the plant.
Okay.
So that's why we have that in blue. If it's above 80%, we'll have a blue highlight on it.
Okay, and that explains why I was able to raise 200 bushel corn without
That's exactly right. This is showing you how that happened right here.
Okay.
Now, what we're able to do on the other nutrients, if you look at P and K, we're going to show you that out of that 300 and something species, 40% are going to be able to solubilize phosphorus and potassium. That's the top number, the solubilization number. So that's a good population of those that are solubilizers for those nutrients. Looking on down into the minors, you can see here that iron, zinc, those are all percentages. Calcium, which is a major one in corn, 74%. You probably have for transporting calcium, you have a really great product here that's going to move those nutrients.
Okay.
So really what you have here is a probiotic. You're able to come in and put a product like this down. I don't know if you've ever done a complete digestion. Have they ever talked to you about a complete soil digestion test?
No,
Jared, pull up an example of one of Region Ag Lab's digestion. We'll show Jay what that looks like. So we've, over the course of a bunch of years, I don't know how long you've been farming that ground and how many synthetic fertilizers you put on, but what we were able to show is that when you do a complete soil digestion, this is not looking at the available nutrients, it's just showing the total nutrients that are in the soil. What we're able to do with this is find out you're actually able to see how products like that biological input you're doing with compost can mine these nutrients from existing that are already there. So in this case, we're doing a complete digestion. Just look at the amount of calcium in this field. It's 21,000 pounds.
Wow.
That's there that the farmer's growing on top of, and he didn't even know he's growing on all this rich source of fertilizer. If you look at the phosphorus, 3,400 pounds of phosphorus, And what Lance has done on the right is he's made a equivalent amount of how much fertilizer it would take to get that amount of nutrient in the ground. So in order to get 3,400 pounds, it would take 15,000 pounds of 1152O to get that much phosphorus there.
Wow.
So now you can see where it came from when you're growing 200 bushel corn with that fertilizer addition that's coming from this pool.
So that's showing on, as I go down to nitrogen, it's showing that while we have 6,768 pounds of inorganic nitrogen that's not available, and you would have to put on 14,000.
You'd have to put 14,000 pounds of urea down to get that much.
Wow.
It's already there. And so your product is mining it.
Got ya.
Taking it out of that pool and giving it to the plant.
Got ya. Can you guys send me this? Well, here, I'll just take a screenshot of it there. Okay,
I can send it to you too. This is just kind of an example one that we use. So
okay,
you don't need to do this very often, but if you did one complete total digestion on your fields, just to kind of give you an idea, you're going to be astounded at the amount of fertilizer that's there that you didn't know was there.
Got ya. So is it when you said Lance, is that Lance Gungerson or another Lance?
It's Lance Gunderson. It sure is. The very same. Lance and I talk a lot. We communicate regularly.
Okay. Those are my main questions. So are any of these, do you guys highlight any of the ones that would be negative bacteria or negative FOS with colors, or not FOS, negative fungus with colors, or what is the blue highlights on the report?
From my perspective, and I've been in the soil world I don't see negatives and positives. Now we can look down through there, and you'll usually see this in the fungal species, and there was only 36, wasn't there, in this one? A lot more bacteria.
Yeah, and then the other one.
Yes.
5.
Let me look through those real quick. Jared, scroll up a little. Aspergillus, Trichoceres, Penicillium, Aspergillus. I'm not seeing any. You don't usually find secondary pathogens when they're in a compost. They get eat up really quick.
Oh,
they
good.
don't last.
Okay.
You're getting rid of that stuff.
Okay.
Composting.
Those colors, though, refer to the California Department of Food and Ag. They have an improved microorganism list. So those ones that you see highlighted in blue or gray, that's what those organisms are. They're on that list that California has. So it's not referring to if they're beneficial or harmful.
Yeah, we're just showing that they're listed on the California Department of Food and Ag. That's it. But you're not going to see any, if this has been composting for what, 120 days, 90 days?
Well, when you would have got it, it would have been compost that had been, the one would have been 6 months or more than that. Actually, it would have been. And then the other one would have been.
Those organisms that you would consider bad are usually associated with living plants. And the reason why they're associated with living plants is they're trying to kill the plant to feed these guys that we're looking at here.
Okay.
If these guys are already there, you don't see those.
Oh, that's cool. So like in an unhealthy system, that's why they're getting those funguses that attack the plant. They want that plant to die to feed the microbes in the soil.
That's exactly right. That's exactly right. That's how nature moves nutrients. Think about it. If it wasn't for that process, we'd be wading neck deep in dead plants. So we're able to rely on the energy of that biology in the soil to decompose these plants. It's a very short period of time, make them available to next year.
Sure. Okay. And then what does you guys this test that I've done cost again?
This test is $475.
$475. Okay. Yep. I'm trying to remember the other questions I was going to ask you about.
Have you done a bee crop test on your soils? What the soil samples look like?
No, I have not.
Have you seen a bee crop test?
No, is that what the last one was? How was that different from what you just?
That was a B crop test, but what I wanted to have Jared show you was a corn example.
So that's what
Okay.
this lone butte was sent in and sampled as a corn sample, but I believe it was a compost sample. So we can go through.
Look at that bacteria. Look at that fun, and you can see this was not a good example because look at that fungi to bacteria ratio. You had 1 to 1,200.
Got ya.
So
yeah,
and usually when this happens, you'll see all these pathways blocked because it's not a natural soil. So you don't have good soil here. This is not something you could grow alone. We would look at this and go, "Oh, this is horrible."
Got ya.
All your pathways are blocked. All your functionality is low. We're looking at what do the pathways look like? I bet they're yellow across the board.
Carbon
carbon.
But yes, all your minors and majors are low.
So what we look at in the mineral soil is now we're able to take a product like yours that has these values, using them in a system. Now we can be able to target these pathways. Now, believe it or not, this isn't far off from what some cornfields actually we see. But once you begin to target a product and put it in to see these pathways moving, you really can see that they really amazingly how well the response is in the plant uptake of nutrients. Because what we're measuring here is not the nutrient. We're measuring the pathway or the organisms associated with moving it.
Okay. Can you guys go back to sample A real quick and look at the biosustainability?
Yeah. We don't like this piece of the report, but
okay.
We'll talk about it.
About that, like my functionality looks kind of low. What would I need to do to bring that functionality up? And then biodiversity, 670 species seemed pretty good to me, but the biodiversity is not very high.
This is an index that you got to remember when we do our database and we're looking at this. These two indexes come directly out of the B crop soil test.
Okay.
We're looking at functionality of the organisms in a cropping system.
Oh,
you have a product, you're not going to show good functionality with the product because we're looking at the database or looking at the organisms associated with just the organisms in that product. So these two indexes that we look at here really aren't that important with a product test. I wish we took them off. I wish we would take them off actually.
Sure. Okay.
Because it doesn't give you a true value of what we do show though is the functionality. If you go on into the report, looking at the benefits of hormone production, let's say. So out of the 600 species, 13%, 2%, and then the stress adapters were, not all that strong, but where your strength really comes from is in your nutrient movement.
Yeah.
The ability for those that's a percentage based on the total species count.
Okay. What is 670 different species good for a compost sample?
Yeah, that's about what I would see in a good aerobic compost sample. That's normal.
Okay. All right. I think those are all my main questions on everything. I mean, to be real honest with you, like the 470 seems high, but at the same time, I really want to know, if our compost are dialed in and if what we're producing is going to be beneficial to our soils. And, where I have a YouTube channel and I'm putting out information to people to try to help them, inspire them to try, these sustainable practices. I really want to know what I'm making and how good it is. So I'm definitely interested in sending you guys in more samples next year.
Okay. And if you want to do a complete soil digest, do you know Lance? Do you talk to Lance at all?
I talked to Lance in 2018 when he was at the Colorado Conservational Tillage Association's conference, the no-till.
Boulder.
Yeah. It's
I was at that. I'm surprised I didn't meet you there.
Burlington, Colorado.
Burlington. That's right. Yeah, I was at that event.
This year?
No, in 18.
Oh, okay, got you.
But you know what you ought to do is send in a sample and let Lance do a digestion on it. You'd be
Okay.
amazed. Yeah. It's only like $50, I think. It's not very much.
Okay.
You won't want to do it every year, but if you're mining your nutrients from your existing fertilizer that you have there, which it sounds like that's what you're doing, it'd be interesting to see how much you've got, right? What your bank account is.
Well, and that's my other question I was going to ask you is so is that the test that you were referring to earlier? Is that
that's
the test?
One? That's the one that he's going to send you. That Jared's going to send
this
you.
one here.
Yeah. Right.
Gotcha. That's the one that Lance can do.
Lance can do this. Yeah.
All right. Yeah. The other question I was going to ask you was as I stop using synthetic fertilizers and I am using cover crops in my rotation, I'm going corn and then cover crops grazed off with cattle. Will I be able to continue to not put down fertilizers and utilize the micronutrients from the dead plants and from the manure the cattle are putting down?
Yeah.
Okay.
Have you ever looked at vermicompost at all from cow manures?
I know I have a friend that does it. I was just trying to get good at the Johnson Su, but are you seeing better results or different results?
I'm seeing
from the
amazing results with vermicompost, especially the vermicompost extract.
Okay.
Yeah. It's hard to get it though. It's hard to find it.
Well, I would just need to make my own.
Yes, right. But coming from cow manure is the best source there is for stress adapters. It's one thing to have the bacteria, yeah, because you think about what's going through the gut of that organism and the bacteria. So you really have the ability to build up your exopolysaccharide production. I mean, that's what earthworms are actually helping in the soil profile, is give it that crumbly effect.
Okay, so I could add to a worm casting the cattle manure and as source.
Yeah.
Okay. Awesome.
As a food source. Yeah.
All right. Well, yeah, I'll start doing research on that today because
I'll send you a video. I'll send you a video of Jack Chambers, who has a big vermicomposting site in California. We're working with him. That's all he uses. His total food source is cow manure.
Is he dairy?
Dairy, yes.
Okay, yeah. So Zach Wright and Ryan Noss, do you know them?
The name's familiar.
So that they were telling me about that system. About there's a dairy farm that has a huge vermicompost.
He's got about 5 million earthworms in his operation.
Oh, they're earthworms. They're
50 million. They're not 50 million. Well, they're red. They're the little red one. The little red.
Yep.
They're not red wigglers. They're smaller one.
Okay. Got you. Well, in this compost, I've been using earthworms, but on next year's compost, I was planning on using earthworms and red wigglers because I figured the earthworms would travel up and down and the red wigglers would break up and together.
He can actually sell you. He'll even actually sell you worms if you need worms. He'll sell you worms.
Awesome. Can you give me his contact information?
Sure. Jack's a very good friend of mine, so he'd love that. Yeah.
Awesome. Well, guys, I really appreciate this. I don't know that I have any more questions for you or need to take up any more of your time. I'm planning on emailing you and staying in touch and sending you more samples to go over for the 2023 compost.
Good.
Okay.
Well, and if I get vermi stuff done by May, which it only takes three months to break down, doesn't it?
It's quicker than that. What I think it's 90 days. Yeah, 90 days roughly. Yeah.
Nope. Yeah. Because if I get that done, then I might send that off to you this year.
Okay. Cool.
So, all right. Well, thanks a lot, guys. I really appreciate it.
You're welcome.
And I have your permission to put this on YouTube.
Sure. I don't. Yeah.
Yeah.
We didn't expose anybody, did we, Ryan? Did we? I mean, Jared.
No, I think we're good.
Okay. Anyway. Yeah. I'll get this up on YouTube, and I really appreciate you guys doing this, and I'll give a shout out to your company as well.
Very good. Thanks, Jay.
All right. Thanks, Jay.
Real quick, Jacob, it is Biomakers. That's the name of the company.